All right, the first thing we have to do is look at this picture, and we can see it tells us that we're just looking, we want angle XTY, so XTY, have a look at triangle XTY. We are given that XT is, or TX is 15, we're given that TY is 20. Now we're not given XY is 25, but you can see XY is the exact same length as AB, because this is a rectangle on the base, and it says that AB is 25. So I've got all those sides. So if we want to find, it says show that XTY is 90 degrees. Okay, so if it's 90 degrees, then of course Pythag has to work. So we'll just check that. So what is 15 squared plus 20 squared? And hopefully, because it's going to equal that, so we're just going to check that. We say, what's 15 squared plus 20 squared, and then what's 25 squared? Anyway, both of them are 625, so that's all good. I should just go 625, and then what's 25 squared? 625. Therefore, Pythag works. So xt squared plus ty squared equals xy squared. Right, so Pythagoras theorem works. So therefore that's angle XTY is 90 degrees. All right, so now that's 90 degrees, it does tell us we can use similar triangles. So let's use similar triangles here. So at the moment, I've got this, this right-angled triangle, and I'm going to put a little angle here, and then, I don't know, something else here, like a star here. There's my three different angles. Now, if I drop a 90 degree down here, which is what it's telling me to do because I'm looking at TZ, that makes a right angle there. So if I instead draw that triangle with, so that will be Z. That's T and that's X. So we've got the angle at X already, that's our dot. Now we've got a right angle, and because of the angle sum of a triangle, this angle must be star, because it's got to all add to 180. And because that angle X is the same, and we've also got a right angle in both triangles, we can now use similarity to find whatever we're looking for. TZ. All right, so TZ is this side here. So I could say, okay, TZ, I don't like using letters, that's what I'm looking for. So TZ goes from, well, let's just go what side do we know? So we do know this side here is 15, don't we? XT is 15. So let's go on XT. So TZ to XT should be in the same ratio because these are similar triangles. So T to Z was star to right angle. In this triangle, star to right angle is YT, so I'm going to use YT. And then XT was dot to star, so I'm going dot to star, and this one is XY. It's very hard if you struggle with letters. So really that's 25, isn't it? So if I put all those numbers in, what I'm really saying is TZ equals YT, which is 20, on XY, which is 25, and then I'm going to multiply by XT for this one. So XT we know is 15. So if I've got 20 on 25 and I'm multiplying by 15, hopefully you can check we do get 12 centimetres. So just showing by similarity. Hence it says, find correct to the nearest minute the angle that the front face DCT makes with the base. So DCT, if you think of DCT, it's that front slanty face. So if I just change colours for a second, I've just found, remember this is an ABC question, so think about what you found. We've found TZ, and we want the angle the front face makes with the base. Okay, so let's put the baseline over here. And if there's the angle we'd be looking for in here. Okay, so I've got this triangle then that goes like this. There's 90 degrees, that's Z, that's T. This is another, the midpoint of DC. So ABCD, we haven't got an E, so we use an E. So there's an E over here. And so we want that angle there. TEZ, that's the angle we want. So we could call that theta, for example. And we've got TZ, we found TZ, or we're given it, even if we couldn't do that question, we know TZ is 12. And we should be able to work out EZ, because EZ will just be half the whole distance, which is that distance CB, and I think we were given CB. BC, here we go, is 10. So that distance Z to E must be 5, hopefully. All right, so that's nice. We've got two sides, so we can tan theta their old age, and we can inverse tan that 12 on 5, and hopefully that gives you the answer, which is apparently, what does it say? Correct to the nearest minute. Okay, so it should, to the nearest minute, it should be 67 degrees, 23 minutes.